Hello, everyone.
You've probably figured out that this new series is all about generative AI, but with a little twist.
Yeah, we will talk about AI with a focus on using it to create applications using JavaScript. It might sound a bit strange to you to do AI with JavaScript. Everyone knows that the language for AI is Python, right?
Yeah, while it's true that Python is probably the best language to create, train, and fine-tune AI models, it's a different story when it's a matter of creating application using these AI models.
Yeah, most AI models are consumed using web APIs. This means that any language that can make HTTP calls can actually do AI. So, why JavaScript in particular here?
Yeah, it's a good choice for many reasons. First, it's cross-platform and provides seamless integrations between the browser and server-side environments. So it's easy to create applications that runs on the web, mobile, or desktop, along with a server API to support it. It also has a very rich ecosystem of libraries, including very popular ones in the AI space, such as LangChain.js. And it's ideal to consume HTTP APIs from different systems, thanks to its native support for asynchronous programming. And finally, JavaScript has one of the largest and most active developer communities in the world, meaning it's easy to find resources like open source projects, tutorials, documentations, and forums that provide support for developers. And thanks to that, you'll never be alone while troubleshooting your issues.
So yes, JavaScript is a great choice for AI, and in any case, the best language to use when you want to develop an application is the best one you already know. We will cover many topics in this series, starting with the basics, along with examples and demonstrations, all the way up to the deployment and production.
And we'll give many tips and best practices with every video focused on a specific topic. So feel free to either watch this series as a course or jump straight to the topic you're the most interested in.
And if you are looking for more in-depth knowledge on how to develop or for specific use cases, here we have an example support chatbot application based on company data, and we will cover all steps of its development from the beginning up to the deployment on Azure.
Now you'll find different sections in this video. We'll begin with the core knowledge around LLMs, then we'll cover different practical use cases and tools that will be useful when developing AI apps. So let's start with the essential things that you need to know when you're working with LLMs. First, what's an LLM? LLM stands for Large Language Model. It's a deep neural network that's trained on a huge amount of data that's able to perform various tasks using natural language. Its main capability is to recognize and generate text. Next, how do you create an LLM? First, you take as many data as you can from various sources, from the web, a website like Wikipedia, from social networks, from books, from open source repositories, basically everything that you can find, and you feed it to the model. This is a very expensive task that costs a lot of money, and this is how you get what we call the fundamental model. Next, you can fine-tune the model using specialized domain-specific data, and you give it more weight. It's a cheaper task because you use less amount of data, but that's higher quality. You end up with a fine-tuned LLM that may be more useful for a specific use case. To improve the quality of the results, you will reinforce the training by having humans ask questions and evaluate the results. This is a long and complicated process, but ultimately, this is what allows you to end up with an LLM that's better suited to follow instruction and basically gets the results that you want. Now, from a practical standpoint, there are two model types. And just to set things straight, LLM do not think. At their core, what they do is just text completion. So you send some text as the input for the model, and what you'll get as a result is the completion of the text. Just like in a regular IDE when you try to get auto-completion. Let's see a little demo. So here I'll be using GitHub Copilot as my LLM, to test the text completion features. So let's say, for example, I'm setting a comment in there that says print hello to the console. The completion that I will get is what I expect, console.log hello world. Now, if I want to try something different and change the input to say, hey, print hello to a DOM element with the ID root. Now, the completion that I will get from the model is also what I expect, document.element by ID, that in HTML, hello world. So yeah, just by changing the input text, I get a different completion. Next, we also have chat models that are tuned to follow instructions. This is most likely what you've been more familiar with. So if I go back to VS Code, we can have an example with the Copilot chat window in there. This time, I can try to create something a bit more complicated. Let's say, for example, I want to create a function that prints hello to a DOM element with the ID root. And here I get the function that I need as a result along with some explanation. So I gave an instruction and the chat model generated for me the answer. So chat models integrate special tokens to mark the specific parts of the prompt, as you can see in there with the imstart and inam token. But what's a token? LLM don't work directly using the text that you provide. Instead, what they use is called tokens. This means that before being able to understand your request, there's a processing step that transforms the input text into tokens, and we call that tokenization. Here you can see how a piece of code is split into multiple tokens. So, okay, the text is split into small pieces, but why do we do that? Tokens are in fact just numbers, and that's great because AI models can only work with numbers. For example, the word function corresponds to this number here. And in the end, every AI model is trained on specific vocabulary of tokens that they use to understand the input text, but also to generate the output. Now let's talk a bit about the limits. LLMs currently only have a limited amount of tokens that you can use to define the context of your prompts. This is basically how much text that you can use as input. AI models commonly use 2,000 to 4,000 tokens as their context window, which fits about 3,000 words, or said otherwise, it's about 6 pages of a document. We also have newer models that can use more than 100,000 tokens, which means you can fit entire books in there. But you have to keep in mind that the less context that you use, the more attention that you will get, which means you will get more accuracy with your results. Another limit that you have to keep in mind is while these AI models are powerful to achieve many tasks, just like humans, they have biases. Statistical biases to be precise. Because the models have been trained on content created by humans, it can sometimes exhibit the same biases as found in the training content. And that's also why you should not rely on LLMs for any critical judgment or decision without taking some mitigation measures. It's also why at Microsoft we've been deeply committed to responsible AI. So responsible AI is a framework for building AI systems according to 6 principles: fairness, reliability and safety, privacy and security, inclusiveness, transparency, and accountability. For Microsoft, these principles are the cornerstone of a responsible and trustworthy approach to AI, especially as intelligent technology becomes more and more present in products and services that people use every day. And this is not only for us, it's something that you also have to keep in mind when using AI models to build your own applications. Now that you've seen some of the inner working capabilities but also limits of LLMs, let's dive into the practical side of things. One of the essential skills that you need to master when working with LLMs is prompt engineering. So let's have a look at the different practical techniques that you can use to get the best out of AI models in your apps. Let's start by defining what exactly is prompt engineering. Prompt engineering is the process of designing and optimizing prompts to get better results from AI models. You'll often hear some fancy names when talking about prompt engineering techniques, but behind the fancy names, there are simple concepts that you can easily understand and apply. Let's start with zero shot. It simply means that you can generate results without providing any specific example, just using the general training data of the model. Here, I'm trying to translate text from English to French. Hello world in French is bonjour le monde. Because there were enough texts that were provided in the training material of the model, both in French and English, I don't need anything more to get the result that I want. Next, we have few-shot learning. By adding examples in your prompt context, you can condition the output to be what you want it to be. For example, here I have a phrase in a foreign language followed by a colon and the language name in English. We provide 3 examples, and then a new phrase followed by a colon as input. This will hint the model into giving the result that we want. Okay, this phrase we provided is in Swedish. As we've seen in the previous video, LLMs do not think, they just complete text. So when you're asking a question that requires some reasoning, very often they'll get it wrong. Like with this simple problem here. When I was 6 years old, my sister was twice my age. Now I'm 30. How old is my sister? And yeah, most of the time, if you're trying to get a straight answer, it will be wrong. But we can use a technique called chain of thought to force the model to simulate human-like reasoning. If I add this simple phrase, let's think step by step. In the prompt, this time it will make the model decompose the steps needed to get to the results. And by doing that, it will augment the context used to get to the answer, and you're more likely to get the correct result. Now let's cover a few tips that you can use to improve your prompts. The most important one is to always be as clear as possible when writing your prompts. For example, if you want to get a short product description, add as much detail as you can regarding what you want it to say, like saying here that the bottle is 100% recycled and that it comes with no dyes. The more precise your instructions are, the more accurate is the result. When designing a prompt, try to always think about the context to set it right. For example, if you want to extract the key points from an email, define what topics you're interested in so the model will know what to prioritize. For example, here I can say that I'm interested in AI, webinar, and submission deadlines. Sometimes, you do not need complex description to get what you want. Instead, you can use simple cues to lead the model in the right direction. Like here, adding the keyword select will make the model generate a SQL query, even though we did not specify in the query language anywhere. When you need the output of your prompt to follow a specific format, you can define it in the prompt directly. For example, here I want to perform sentiment analysis on a text. If I add that I want JSON output and provide the shape of the JSON, I can get exactly the format I need for my purpose. Remember the few-shot learning technique we've just seen? Sometimes the easiest way to get the results you want is simply to provide a few examples instead of a long description. So here I want to generate 3 brief follow-up questions following an existing user query. Just instead of describing what I want, I can just provide an example. And with the example, I can also specify the format. And if you're trying to ask a complex task that needs some reasoning, or if you explicitly want to know how you get to the generated results, then you can use the chain of thought technique. By asking the model to use a step-by-step approach, you will make it decompose the task and simulate reasoning. Like here in this example, I'm trying to know what sport is easiest to learn but hardest to master. And I'm not really interested in the result by itself, but more into the reasoning and how you get to that answer and why did you pick one specific sport instead of another. Now let's put these tips in practice with an example scenario. Here we are building an AI assistant for our company that's called Content So Choose, and we want to help our customers to choose the right products for them. So I've created first this simple prompt here. Okay, we have an assistant that helps the user with questions. And the question is, what shoes should I use for running? Let's try that for now. So now I already see that there's some issue there. The answer is way too long. So first thing, I will try to precise in the prompt to say, okay, be brief and answer with 2 lines max. Okay, I want the answer to be more compact, to be more brief. So yeah, looks a bit better. But we want the answer to be our company products. So let's give it some context. Let's say this time I want to help the users with questions about products for the company Content So Shoes. Let's try again. Okay, it's a bit better, but now it makes up products that don't exist. So what we'll do is just provide a list of the products that we have and their features. So what I will do is add in the context in there using Markdown, a list of the products that we provide at the Content So Shoes company along with some characteristics. Note that we're using a Markdown table here, which AI models usually understand. You could use CSV or JSON also. No, the result is way better. It's saying that we should use Content So dash, which is the correct answer for that specific question. But let's be honest, the tone is not very friendly here. So let's tell it to be more cheerful. And to do that, I will just say, be cheerful. Okay, a bit better, and I even get some emojis in there. And you know what? Now we could even make it more personal if we could include the user's name in the answer. So let's do just that. So I will say, okay, be cheerful and mention the user's name. And of course, we need to provide it somewhere. So let's say somewhere in the prompt, I say user details and I give it the name of the user. Let's try it again. And now this time we get a personalized answer. Now this is the kind of results that we want. But we would like to consume the result in a web UI, so it will be best to get the results as JSON. So what I can do is that I can hint at the format I want in there without even the need to say that I want JSON. As you can see, I'm just putting the form, the shape of the answer that I want. Let's try it again. And yeah, perfect. I get both the product name and the answer to show in the UI. And now you've seen how you can tweak a prompt to get the results you need from AI models. Let's quickly recap the tips we've just seen to get more effective prompts. So first, be clear in the instructions that you provide. When you can, provide additional context to make sure that the AI model has everything it needs to better understand your request. Use cues to tip the model into the direction you want the answers to be. Can also define the output format explicitly if you have special needs. Sometimes using examples is the best way to get the result that you want. And if you have complex tasks, you can ask explicitly to break it down step by step. And note that you don't need to use all of these all the time, only use what makes sense for your use case. Now, let's continue a bit further with a more advanced prompt engineering technique called Retrieval Augmented Generation, or RAG for short. This technique is a powerful way to improve the accuracy and reliability of your AI outputs. Let's see why it's useful and how you can use it in your apps. When working with AI models, there are some challenges that we're facing. LLM sometimes makes mistakes when generating information, and the data that has been used to train the models may be out of date or may come from shady or untrustworthy sources. This makes it difficult to tell if a generated information is correct. To solve these issues, we can use a technique that's called Retrieval Augmented Generation, or RAG for short. RAG is a combination of two components: a retriever that will fetch relevant information from a knowledge base that you control, and a generator that will create the answer. This combination allows for more precise and relevant answers by using data that you provide instead of relying on the model's training data. Now, why is RAG useful? It's cheap because you don't have to spend money to train expensive models, you can use the existing one. You maintain the knowledge base separately from the AI model, and you can even use multiple data sources. That means that the data that will be used is always up to date. It generates factual responses using a specific context made of information that you provide instead of relying on the AI training. Answers are grounded into your context and not the model's knowledge. And because you're able to show what documents were used to generate the response, users can check it by themselves if needed and see that they can have trust in the answers. Now, how does RAG works? First, the user asks a question. The retriever will search for information in the knowledge base and return documents that are relevant to answer the question. Then, you send both the question and the documents to the generator that will create the answer based on the information provided. And how to implement that? First, you have to create the knowledge base. You extract text from documents, then send it to a special AI model called an embedding model that will convert your text into a vector. Vectors allow us to capture the semantic information of the text as opposed to just capturing the lexical information using the words. Said differently, the meaning of the text is retained regardless of the language used. Next, you put together the vector along with the original text to create a document and store it inside a vector database. You repeat this process for every document that you want to include in your knowledge base. Once you've built your knowledge base, you can perform the retrieval and context augmentation process. And this process is done in 3 steps. First, we transform the user query into a vector by sending it to the same embedding model that we used while creating the knowledge base. After that, we use the vector to search in our vector database for relevant documents, and we pick the n-best results. Finally, we take the text from the most relevant documents as well as the initial user question and use it to craft a prompt. It should be something along these lines, like answer the user's question using the provided documents. Then you send the prompt to the LLM to get your answer. Let's have a look at a practical example of using RAG for a support chat application. So, for the Contenso real estate company, we've built this experience that allows customers to ask support questions about the usage of its product. Here you're looking at the final deployed version on Azure that uses a set of company documents in PDF format to answer the questions. For example, let's ask a question about the refund policy. Great, we have an answer. But the important part is that the answer cites the documents that were used to generate that answer. And I can even open that document to check it by myself if I want. So let's look for refunds. And then you can see the information that was used to generate the answer. Now, if we try to ask something that's not in the provided document, Let's see what happens. Like, for example, how to deploy this app on Azure. It simply says, I don't know, because that's what we told the model to say when it can't answer a question using the documents that we provide. Now, if you're interested in this sample, you can have a look at the links in the video description or here, and be sure to take a look at the other videos in the series to learn how we made it. You've seen that including external data sources can help getting better AI outputs, but surely it also increases the complexity of your app. That's when it may be useful to rely on a framework to abstract some of the complexity of your AI workflows. So now we'll talk about how you can speed up and simplify your AI developments using the LangChain.js framework. The generative AI field is evolving very fast and there's still so much to explore. When things move fast like this, you need to be able to experiment and iterate quickly. First to validate your ideas with a prototype, then to scale up to production if it works. Now let me introduce you to LangChain.js, a JavaScript library for working with large language models. If the name sounds familiar, it's because it's the sister project of LangChain, which is made for Python, and it's one of the most popular open source projects in the AI community. It's a great tool for experimenting and building generative AI apps very quickly. So what's LangChain.js? LangChain.js is an open source JavaScript library for working with LLMs. It provides high-level abstraction for all the components you might need when creating your AI application. And thanks to the compatibility layer, it makes it easy to swap components like models or vector database, allowing to quickly switch from local to cloud resources. It also gives you all the tools that you need to create complex workflows that use your own data like RAG applications. Now let's take a look at some of the core concepts of the framework. LangChain includes helpers to create prompt templates. It allows to inject user input and parameters or augment the context of your prompt dynamically. In this simple example, we have a chat prompt template to generate jokes on a specific topic. And when invoking the template, we can set which topic we want and the placeholder in the prompt will be updated. This is especially useful when you're building complex workflows where the prompt is augmented in different steps. Now, speaking of workflows, LangChain was built to compose complex AI workflows made from multiple processing sequences. Here, we're using a prompt template with a few components. Let's detail how it works. First, we define a type for the output object that we want. We initialize a chat model. Here we're using OpenAI's GPT-4o mini. Next, we define our prompt template, where we also ask the output format that we want. Then we create a parser to transform JSON into an object conforming to the joke type that we define. And we define our workflow called a chain. We take our template, we pipe it to the chat model to generate the response, and pipe the response to the output parser. And finally, we invoke our chain with our parameter, and we'll get our object as a result. LangChain provides many components that you can use to build your AI application, and we've already seen a few. We have chat models that provide a compatibility layer, allowing you to switch between AI models from different providers easily. It makes it very easy to compare different models' results or to switch from local to cloud models. And it's the same for embeddings when you need to transform text into vectors. There are all sorts of documents helper to load data from various sources and formats, like Office documents, YouTube videos, web pages, GitHub repos, and more. You also have everything you need to process the text from these documents, like splitting it in smaller pieces or automatically tagging the content to add metadata. Then we have the stores and retrievers. Vector stores allow you to store documents and perform vector search, while the regular store is used as a memory to save your chat sessions. Retrievers can be used to load documents from various sources, including a vector store, to implement the RAG pattern. And finally, we have tools which are functions that can be called by agents to perform various tasks, like generating an image, executing code, querying an API, and more. Let's see a practical example of how you can use LangChain.js to quickly create an application prototype that works locally first and then deploy it to Azure. For this demo, I wanted to build an API where I can send a link to a YouTube video and ask a question so I can get an answer without having to watch the video. Let's see how we implemented that with LangChain.js. So first, because we're working on a prototype, we'll just hardcode the YouTube video URL here and the question. So this video was the last Microsoft Ignite keynote, which was about an hour long. And I would like to get an answer to a simple question. What were the news about GPT-4 models that were announced during this video? So let's see how to implement our prototype in there. First, we'll use the YouTube loader component to load the transcript of the video. We specify that we want it in English. And once we've loaded the text from the YouTube video, we'll use the recursive character text splitter component to split this huge amount of text. Remember, it's more than 1 hour of video. That means that we have a lot of text. We want to split it in smaller pieces of text, so the RAG process that we'll implement will be able to be more accurate, to more finely accurate the piece of content that it needs to answer the question. So here we use chunks of 1,500 characters with some overlap. We run the splitter on the raw text to get our set of documents in there. Next, we initialize the model and database. And here I'm using Ollama with local models that I'm running on my local machine in there. So I'm using this very small embedding model to convert the text into vectors, and I'm using the llama-free model to generate the answer. For the vector store, I'm using this local store in there. Next, to create my knowledge base, I can do that in one simple call in there on my vector store, add documents. What it will do behind the scene is for every piece of documents, every piece of text that we generated above, we will create a vector and we'll store the vector along with the text into our vector store. Next, we create our processing chain. So here we have our template first. Answer the user's question using only the sources below. And we put a context placeholder where we will inject the result from our vector search. And then we inject the human question here in the input placeholder. Next, we create a retriever from our vector store so we're able to search for matching documents. We implement the RAG chain in there using a LangChain component where we simply give in our prompt and the model we want to use to generate the answer. And finally, we invoke our chain here by passing in our user question and the documents, invoking the retriever to perform a vector search that will return the best matching documents that might be able to help answer that question. And finally, we just print the result to the console. So let's see how it works. Now I get the answer for my question, what are the news about GPT-4 models? So, according to the text, there is an announcement about GPT-4 Turbo model being available in Azure OpenAI service. Additionally, there's GPT-4 Turbo with vision, allowing to prompt with video images. And yeah, it's the same price as OpenAI. It's also mentioning that fine-tuning of GPT-4 and OpenAI service will be introduced. So yeah, that sounds about right. Now, the next thing is that, okay, I have a working prototype in there that works entirely locally. But what do I need to change if I want to take this prototype and make it a production application that will be able to run on Azure? Let's see the changes that are needed to the code. First, we'll update the imports. So instead of the Ollama and local database, we'll be using Azure components. As for loading documents, nothing has to change in there. Next, we'll see what we have to change in the model initialization. So instead of Ollama embeddings, I want to be able to use Azure OpenAI embeddings. Same for the chat model. And again, the same for the Azure AI Vector Store. So we'll be using Azure AI Search as our vector database in there. Before embedding the documents, since we are going to production, we'll just add a simple step in there to search if documents are already indexed in our database before running the process again. So, okay, that sounds about right. I take the video ID from the YouTube URL and search if I already have some documents inside my database. And let's say that if I don't have documents in there, I run the embedding process. Just a simple change. Next, regarding running the chain, I don't have to change anything because of the LangChain abstraction layer. So I can just swap in the components like I just did with the models and vector stores, and everything else is basically the same. So now let's try running this again. And here I get my answer with slightly more details because it's using a GPT-4 Turbo model to answer a question about GPT-4 Turbo. So we get more details about the introduction of GPT-4 Turbo with some features, about the pricing that we've seen, GPT-4 Turbo with vision and fine-tuning. So basically the same answer with a slightly different wording. So this time I have a code that is able to use Azure components. So the only thing that I would need to do to be able to run this code on Azure is basically put all that code inside a serverless function so I can run it as an API. If you want to take a closer look at this demo, you'll find the link to the GitHub repo in the video description. When working on any app development, it's often useful to be able to experiment and test your app locally before deploying it to the cloud. This is especially true when working with AI models. Thankfully, we have tools such as Ollama that can help you do just that. So let's see how you can install and use local AI models on your machine using it. But first, why use local models at all? It allows you to experiment with AI and build prototypes of your application at no cost. And because everything runs locally on your machine and you don't have to set up cloud resources and access, you can have a fast inner development loop. And also because everything's local, it means that you can develop without requiring an internet connection. It also makes the testing of your application easier and cheaper, especially when you have to evaluate your AI outputs against many different metrics. Now, the question that usually comes next is, what are my options if I want a high-quality local model? We've released the 5.3 model family, which is a series of small language models, or SLM, that provides great performance, especially for their size. The test shows that their performance is on par with much larger models such as GPT 3.5, and they include responsible AI safety alignment to prevent harmful content from being generated. And they are also tuned to follow instructions, just like your regular chat models. In particular, the mini model version is especially interesting as it can run even on devices with moderate specs, like mobile devices. And they're available in many platforms, but the easiest way to run 5.3 is using Ollama. So what's Ollama? Ollama is an open source tool that uses the llama.cpp server under the hood, which is one of the most active inference servers in the open source community. It allows you to run SLMs and LLMs on your local machine and is optimized for both CPUs and GPUs. And you can use it to download models directly. It provides a library of quantized models, which are optimized versions of the models at the cost of some quality loss. So that means that you can choose your trade-off between speed and quality depending on your needs. And finally, it comes with an OpenAI compatible API, so it can work with the already existing applications and makes it easy to swap in the model that you're using when working locally or deploying to the production. Now, let's see how it works in practice. The first thing you want to do is to go to the oliama.com website to download Oliama and install it on your machine. You can also have a look at the model library that it provides. If you select one model, you can get more details about it and see all the versions that are available. One of the first things you might want to do after downloading and installing Oliama on your machine is download a model. You can do that by running the command oliama pool followed by the model name. In our case, we'll be using the 5.3 model. You can also use the command oliama list to see all the models that you've installed and downloaded on your local machine. Now, what can you do with Oliama? Maybe you want to run a UI to play with the model. By running this docker command, it's starting a UI on my local machine that uses Oliama as its backend to run a ChatGPT-like interface. Now going back to the browser, if I open the localhost on port 3000, the first thing I'll see is this web UI. So first, you have to create an account. So you can say just about anything because it's all local on your machine. So let's go. First thing, you need to pick up a model. So let's use 5.3 to see what it can do. And then let's try to see one of the example prompts. So let's see, for example, give me some ideas of what to do with my kids' art. And now, as you can see, I get an answer from the model, except that everything, including the AI and the model, is running fully locally on my machine. Okay, this is great, but I'm a developer and I want to develop application using that. So let's switch back to VS Code and play a bit with the HTTP API. So first, Oliama provides an endpoint to generate text completion. So for example, I can send in a prompt, choose the model, and specify a few options in there. And then if I send in the request, I can get a result. Okay, so this is hello world in Japanese. Next, I have a more conventional chat completion API. So using just something that looks like the OpenAI API, can send it your system prompt and your user prompt and get the answer right from the API. So, in French, you say bonjour, in Japanese, konnichiwa, and so on. You also have an API to generate embeddings. So this time I'm using a different model because for embeddings, you have to use dedicated models to transform the text into vectors. So here I can send a few text in there, send it to the model, and I'll get back the vectors as a result. So this is my first vector, and this is my second vector. And one of the best things with Oliama is that it also provides an API that's compatible with OpenAI. So that means using existing tools and SDKs, you can query Oliama just like you would do using the OpenAI API. You can even set to use JSON mode in there, and you can see that I get an answer that is basically the same as the one you will get from the OpenAI API. That also means that you can use the regular OpenAI SDK to connect to Oliama, just like you would do in your application. So here, I can just set the base URL to my Oliama local server. The v1 is the OpenAI compatible endpoint in there. I still need to provide an API key even though it's not used by Oliama. And then I can use my familiar OpenAI SDK to create completion. So, let's see some talk in pirate style. So let's run this example. And here we get the answer. Oliama is great for experimentation. You still need a fast internet connection to download the models and a good machine to run them. But even if you don't, you can still experiment with AI models. Some models are lightweight enough to run directly in a browser-based environment, like the 5.3 model family. So let's now use an online playground to experiment with 5.3 directly from your browser, for free and without any installation required on your machine. For that, we've built an online playground that you can use for free on any machine that can run a web browser, so you don't even need a fast GPU or CPU. And this is meant to be interactive, so go ahead and open that link that you'll also find in the video description so you can play along. So if you open this link, it will open this GitHub repository. From there, select the Codespace button in there, and it will ask to create a Codespace. A Codespace is an online development environment that you can use directly from your browser. You need a GitHub account for that, so if you don't have one, you can create one for free. Next, select Create Codespace, and then it will take a few minutes the first time to create the environment, so you can just go grab a cup of coffee and wait till it's ready. Now we have something familiar. It's the very same VS Code editor that you know, but right into your browser. So first, let's use the terminal to check that everything works. So type in olyama run 5.3. So by running this command, I can chat with the model. It's like a minimal ChatGPT right in my terminal. I'm hearing my cat meowing in the background, so for inspiration, let's say create an haiku about a hungry cat. And there, I get the response from the model. So everything looks good in there. So you can play a bit with the model, and once you're done, you can use Ctrl-D to close the chat. Next, let's open this Olyama notebook in there. This is a Jupyter notebook, and it allows to mix markdown text along with code to create interactive experiences. First, we define the model in there. If you want to play with different models, you can do it by changing the constant in there. Just make sure that you download the model with Olyama first. Now, for every code block that you see, you can modify the code if you want, and you can get this button on the left that you can use to run the code. Make sure to run it at least once every time you see one to make sure you set the context right for the notebook. Next, we set up the OpenAI client so that we can make calls to the model. Olyama provides a compatible API, so we just have to set the base URL in there and put an API key, even though Olyama don't need it. Let's run it, and now we can play with the SDK. Just notice this npm prefix here in the import. It's because we're using Dino as our runtime to run TypeScript in the notebook here. It wouldn't be needed if you're using Node.js. So now that we have set up the OpenAI client, we can use it to generate a chat completion. So again, we use the SDK, we specify the model name, and send it our prompt. Let's run it, and here we get the result. Now it's your turn to play with the notebook. We have more examples here with prompt engineering, few-shot learning, and even retrieval augmented generation. So once you've completed the notebook, we also have a few samples in this folder in there. You can open any of them, like for example, this classifier one. And then you can run directly the example using the run button at the top. So here, what I'm trying to do is extract the sentiment of a text using JSON format. And here we get the result. So this is mostly positive, not too much aggressive, and in French. Now it's your turn to play with generative AI, and the best thing is that you don't even have to set up anything. At this point, we've already covered a lot of ground, from the basics of LLMs to advanced techniques like RAG, and even started to experiment with AI models. In the next part of this series, we'll dive deeper into how you can use and deploy AI models in the cloud to build and deliver AI apps to your users. Now, I'll let Corey talk about Azure AI Foundry, which was formerly known as Azure AI Studio.
Hi, everyone. My name is Corey Pace, and I am a cloud advocate here at Microsoft. I'm really happy to be delivering this lesson for you entitled The Introduction to Azure AI Studio. If we think the generative AI with JavaScript is a journey or a trip into the world of building with generative AI applications, I think the Azure AI Studio is a bit like the airport for that journey. It allows us to go to the places that we really want to go to, but without all of those things that make airports not fun, like long lines and delays. So let's really get into this. As an agenda for today's lesson, we're going to look at first how we sort of organize things within the Azure AI Studio. This is called hubs and projects. Then we're going to explore the model catalog. This is where we keep all of the large language and small language models available in the Azure AI Studio and give you relevant information how to work with them. Then we're actually going to deploy a model, test that model in the playground, and then lastly, tour some of the other tools within the Azure AI Studio that might be relevant to you as you start building. So I'll start by saying that we continue to improve the Azure AI Studio. So if you're looking at the AI Studio now, it might be looking at slightly different than what you might see on your screen now. But never fear, don't worry. Many of the main concepts are going to be the same, so maybe the UI might have been adjusted a little bit. So first thing we'll do when we enter the Azure AI Studios, you might be seeing either recent projects, or if this is your first time setting it up, maybe also trying to set up a hub. To continue this analogy of airports, I would like to say that if you think about a hub being at the airport, which is where we can kind of share resources. So in airports, we have runways, gates, things like that. And a project is a plane, right? So they use some of the resources in there, but they also have their own kind of intent or purpose to be working with. So the first thing we'll do is actually start a new project by doing this, clicking on this new project button here. You will see first a project name that's sort of just given as assignment. You can change it to anything else that you like. Let's just call this one JS GenAI. And then a hub. Like I said, this is going to be where you're sharing all the resources, even if you're working with other team members. You can have one hub to sort of rule them all while having different projects that you're working on specifically. If you ever get confused by this, we always have these tooltips to give you a better explanation. So in this case, right, a hub is a providing hosting environment. And if I wanted to, I can also create a new hub right here on this page. I'm going to go ahead and create a project here. And what this process is actually going to do is going to start launching the different various services that I will need to actually use in terms of building with this application. I promise you no wait times, or at least no long wait times like airports. So I'm actually going to cancel this because I already have a project running. So this is my project here. Actually, I can go ahead and click on that. And I can also see certain things in terms of the hub that I'm working with, the resource group that's attached to this, as well as in terms of what subscriptions that are attached to that particular hub. So this is where I'll get all that type of information in terms of how this actually connects to the larger Azure resources that I'm using. But the first thing we're going to do when we're building with any sort of generative AI applications is we need a model, right? So if I go to this getting started, the model catalog, this is where you're going to find out all of the models that are available within the Azure AI Studio. And we have a lot of them. We have right now, at the time of recording, 1,757 models. I bet you that if you're looking at this tomorrow, that we might have 1,557 or 8 of these models. We continue to add models that we get feedback on that need support, as well as the industry as a whole are continuing to innovate and drive new models, as well as even specialized models there. So you might be asking then, how can I find the model that I want out of all of these? The first thing I like to do is using these filters here in the middle of the screen. So we can divide these things into certain collections. So these are primarily the model providers, whether there's the Azure OpenAI, so connected to the Azure OpenAI service, Microsoft which is coming in from our research models, or even our small language models like 5.3 and 5.3.5. The meta models, so this is the Llama family, and also the Mistral models. So just even by clicking on this, you can find specific models based on their providers or their collections. We also have different deployment options within the Azure AI Studio. You can get information on exactly how these are different in terms of managed compute and the serverless API. One is sort of on a pay-as-you-go billing, while the other is also attached into having a hosted reference. So this is the managed compute option. So knowing these differences is kind of important, especially when you're choosing the models that you want. I think the probably the most important one in terms of finding exactly what you're building based on that is the inference task. So a lot of these models can do many different things in terms of providing it information, answers, responses, things like that. But there's also models that are quite specialized in certain inference tasks or things that we want to do in the application. So we can go in and look at either things like chat completion. So this will drive your sort of chat-based type of applications. Or we can even do things like text generation in terms of just generating some sort of text. And even more specific cases like embeddings, for example, where you're using things like the RAG frameworks, which will be where you want to find those models to generate embeddings in your data, as you can see here. We won't go too much into detail here about fine tuning, but that's also an option. This is again training a model into doing specific tasks based on a large amount of data sets that you would provide. But in this case, let's just go ahead and go to the Azure OpenAI collections, and we'll do all of these. And let's go ahead and deploy a GPT-4o model. So what you see in this model catalog as well is a description of the model. This is going to be important if you've never heard of that model or you want to get an understanding of exactly what the model does. We'll also give information about version numbers, so models continue to be updating, and even some additional features. For example, this model has JSON mode, so I can request or make a parameter that the responses are always going to be in JSON, which is really important if I want to use that later on in my application, as well as function calling. So I can take the response of the large language model and actually make a call within the function of my application, or maybe an API call. So we will go ahead and deploy this model. I already have one deployed, so it's going to give me this nice little 2 prefix. And you'll see the version number, the deployment type, which I'll talk about later on, was the project that's attached, as well as the resource location, which is going to be important in terms of where you deploy this. Anytime I can go ahead and customize these sorts of things. For the deployment type, we recommend using global standard for development. So I'm going to leave that, and as well as the model version as the default. But if I wanted a later or earlier model, I can actually do that as well, which could be important when we're talking about compatibility of the tools that you're using. All these models also come with a built-in content filter. So we have these default filters within them. We'll talk about that later on in terms of what it actually means. But you can go into this tooltip here and find out exactly what is being filtered out and at what level. So I'll go ahead and deploy this model. And once the model is deployed, it's really time to see it working, see how it functions. And you can go in and maybe start making API calls. You have the endpoint here as well as your key. But what I like to do is actually start opening this in the playground, which is also within Azure AI Studio. So if I go ahead and click on that, this is actually going to bring me into the chat playground. And based on the actual model itself, you'll be able to use different playgrounds here. But in this case, I'm going to just use the chat because I will be able to then kind of test out how this model is functioning based in a chat context. Whether or not my application is a chat application doesn't really matter, but this is a great way to just get started. In this chat playground, you'll see a couple of things. One, I can determine what the system message is. This is essentially sort of the rules within the application, as well as start chatting here. What I would like to do is, since this is a multimodal model, I'm going to use some of the vision elements of this model by going ahead and attaching an image from this so that I can see exactly what that image is and maybe it explains to me. So what is this and how does it work? So now we have some JavaScript code to be on theme, and it's going to not only understand what's in the image, but actually going to explain the code to me, which is really great for anyone learning JavaScript, and maybe they have a screenshot, for example. But this proves that the model is working. I can go in and view the code in terms of making any samples. Which right now we have the JSON examples and curl examples that could be relevant, as well as even doing any type of evaluation later on, both in the manual and automated way. So that was getting the model deployed, choosing it from the catalog, and testing it out. We have a lot of other tools within this Azure AI Studio in terms of prompt flow, so managing your tooling as well as the flow of how it's working, interacting with the model, and an evaluation, as well as fine-tuning. But these are all topics that will come up later in this course, so good luck and keep building.
Thank you, Corey, for this great overview of Azure AI Foundry. Now, if you're building AI apps, you're also likely to need a way to load and store data at some point. That's where Azure Cosmos DB comes in. We'll now see how you can use Cosmos DB to build generative AI apps and where it can be useful.
Hi, everyone. I'm James Cadella, Product Manager in Azure Cosmos DB. Today, I'm joined by Johan, and we're going to be talking about building generative AI applications with Azure Cosmos DB in JavaScript, and Johan's going to show us a great demo at the end. Let's get into it. So we'll start out talking about vector indexing options in Azure. Then we'll dive into Azure Cosmos DB for AI apps. We'll look at some generative AI use cases with Cosmos DB. Then we'll go into that nice JavaScript demo that Johan has prepared for us. So you have many options for choosing vector indexes or a vector search solution in Azure today. You have any of the Azure databases offerings, and these are preferable when you have semi-structured or operational data, where you want a single source of truth for your data and to do vector search and retrieval augmented generation for your AI applications using one database. We also have Azure AI Search. Azure AI Search is a very powerful search service that you can also use for vector search or full text search or hybrid search. Has a lot of great capabilities, advanced capabilities for more relevancy in the search process. It also is able to index files or documents or data items from multiple different sources. So if you have data in Cosmos DB or blob storage or Postgres or some combination of all of it, you can have Azure AI Search be the single sort of indexer over that entire data. So multiple different options. If I want a single source of truth, I can use a database. If I want maybe multiple sources of truth or multiple sources of data, I can use Azure AI Search. Really, really powerful options for every single scenario that your application might have. So let's talk a little bit about Azure Cosmos DB. In principle, we have two flavors of Cosmos DB. We have our Cosmos DB for NoSQL offering, which is our core Cosmos DB offering. And we also have a Cosmos DB for MongoDB offering. Both of these offerings have vector search capabilities and are great for AI applications. Azure Cosmos DB for NoSQL is what we'll be talking about here. And here we have multiple different options, including, there's a serverless option or a provision throughput option with autoscale. So you pay for compute that you use, or you can pay for provision compute and then take advantage of our high elasticity. So when demand picks up, Cosmos DB will automatically scale out for you and scale back in when that demand subsides. Cosmos DB for NoSQL also has low latency data transactions. You can often do reads and writes in under 10 milliseconds, which is really powerful. Also offers mission critical reliability and vector search with a new vector indexing type called DiskANN, which we're really excited about to offer very cost efficient and performant vector search at any scale. So there's lots of different scenarios that our customers are already building AI applications with Cosmos DB for NoSQL. We're going to talk about a few of them here today. So there's chat history. So as I'm talking to a large language model, maybe I have a chatbot application, I might want to keep a record of the conversation that I'm having with the chatbot. And then this is really powerful for doing auditing later, or maybe providing context on previous conversations to the chatbot. We can also do retrieval augmented generation, which is about bringing the right data at the right time from your database to personalize your large language model for your specific scenario or application. And we do this today using vector search. So also lots of use cases for multi-tenant apps, real-time recommendations, anomaly detection, and even multi-agent AI systems. So lots of use cases today that we have thousands of customers building these incredible applications using Azure Cosmos DB for NoSQL. Customers like OpenAI, TomTom, KPMG, ASOS, and MasterCard, and more. So let's actually double click on the OpenAI scenario. So ChatGPT scales very well with Azure Cosmos DB. All of the chat history for ChatGPT in order to maintain session consistency between previous sessions or previous topics you've talked to ChatGPT about. All those conversations are stored in Cosmos DB. And OpenAI chose Azure Cosmos DB for our low latency and for our high availability and scale architecture so it can seamlessly meet the demands of their ever popular application, ChatGPT. Now, let's talk a little bit about some of the use cases, right? We did it at a high level. So there's some really specific use cases that customers have built their applications on with Cosmos DB. The first is a vector and operational database in one, right? So you don't need to store your data in one database and have a dedicated vector database for your vectors or for vector search. You can actually store all of this together in Azure Cosmos DB for NoSQL, right? A vector is just a list of numbers. A list of numbers can be stored as another property in my document or data item in Cosmos DB. So you can store everything together in one place. This means you don't need to ETL data to another resource. You can maintain data consistency, and it reduces the complexity and cost of your AI application architecture. Built on top of that is this notion of retrieval augmented generation, bringing your own data to a large language model so you can personalize it for your scenario. And you can do this today with very high speed, high efficiency using Azure Cosmos DB. Chat history. I talked about how OpenAI uses Cosmos DB to maintain chat history for ChatGPT. It's really good for this conversational context, but also for analyzing, where does my AI model or my AI application perform well? Maybe where does it need a little bit of help? So you can actually use it for auditing or improvement purposes later on as well. And then finally, there's also this notion of semantic caching, which is getting very popular. Semantic caching basically plays on the last two topics, retrieval augmented generation and chat history. Basically, if I'm already logging chat responses or questions from users and responses from a large language model, I can actually vectorize these and take advantage of them later. So if I see a user question that I've seen previously, rather than send this question to my large language model, which is oftentimes, if I make that API call, it has a very high latency or high cost associated with it, especially if I'm using a state-of-the-art model like GPT-4. Instead of doing that, I can just vectorize the user's question and then do a very fast and efficient vector search for all the questions that have already been asked that I've stored in Cosmos DB. And if I see the same question or a very similar question, I can just leverage a historical response from my large language model that I've logged into my Azure Cosmos DB resource. So this is a really great way to take advantage of things that you've already cached or stored in the database, and you can just use to reduce latency and also reduce cost of your AI application. So lots of great use cases, and we'll see some of these in the demo that Johan has prepared for us. Okay, so I mentioned that we have vector search in Cosmos DB, right? So we can store our data and our vectors together in one database, in one data item that reduces our complexity and overall cost of our AI applications. Not only can I do vector search, but I can also apply any of the existing query filters that we support in Cosmos DB's NoSQL language today, right? So any sort of equality or range or query filters I can use as well. And we offer multiple indexing types, from a flat or brute force or exact search to a quantized or compressed flat search, and then even DiskANN, which is a new algorithm that we're making available in a Microsoft product for the first time that allows very efficient vector search at scale. And this is something that was developed internally at Microsoft Research. We've used internally in Microsoft products, and we're really excited to bring it to you for your vector search scenarios in Azure Cosmos DB for NoSQL. And this is all built on top of all the goodness you get with Cosmos DB, the serverless supervision throughput model, built-in multi-tenancy, instant and dynamic autoscale, all the goodness that we had talked about, including our industry-leading 5 nines of availability. You get all of this in your vector search scenarios. So it's really powerful stuff here. And I mentioned that we offer our DiskANN vector indexing algorithm for the first time in a Microsoft product. And the way it works to actually achieve this efficiency is you start off with inserting your vectors into your document or your data item in Cosmos DB. And those vectors are compressed. The compressed vectors are stored in an in-memory index, and the uncompressed or full fidelity vectors and the full graph data structure for the index is stored on high-speed SSDs, which make up the backbone of Azure Cosmos DB. And so when you go and do a vector search, it can start off searching through some of the compressed or quantized vectors in RAM, and then leverage the complex graph that gets created that's stored on the SSD. So this hybrid approach of using both RAM and hyper-fast SSDs allows vector search in Cosmos DB to be very fast, but also very cost efficient, because leveraging the high-speed SSDs is much, much, much more resource easy, not as computationally expensive as using RAM. So it makes vector search very cost effective, very cheap, very high quality in Azure Cosmos DB for SQL. Okay, so I've done a lot of talking about how great Cosmos DB is with vector search. Let's take a look at what that looks like in JavaScript with LangChain.js. So we'll hand it over now to Johan to show us what he's got.
So hey, thank you, James, for all these details. Now let's have a look at a practical example of using Azure Cosmos DB for a RAG application. Now you may already have seen this support chat application that we built in the previous videos. So here we're asking support questions, and all the answers comes from the PDF data that was ingested and vectorized in Cosmos DB. Now let's take a quick look at how we implemented this. So here we have the function that ingests the PDF documents. So let's skip to the most interesting part in there. So the first part is that we need to extract the text from the PDF using this component from LangChain.js. Next, we split the text into smaller chunks to improve the accuracy and allow multiple chunks to fit into the LLM context. And then we need to transform this text into vectors and store them into the database. To do that, first, we need to initialize the embedding model. So we do that by creating this Azure OpenAI embeddings object in there. And then we only need a single line here to convert all the chunks into vectors and store them into Cosmos DB. That's because we built in an integration for Cosmos DB right into LangChain.js to make it easier to use it. And now, to use these documents to perform the RAG process, we go to the implementation of our chat API in there. So first, we need to initialize everything that we need. The embeddings, the chat model, and then our Cosmos DB vector store integration. We still need to pass the embedding model in there to be able to convert a question into a vector so we can perform the vector search. Next, to use Azure Cosmos DB as our retriever component, we make this call here to say that we want to retrieve the top 3 documents when performing a vector search. And finally, we invoke the retriever with the question to do the search, and it will take care of vectorizing the question, doing the search, and returning the matching text so that we can inject that into our context. Of course, you can go further and fully customize the process, like choosing which algorithm you want to use. But if you're okay with the defaults, it's as simple as that to use it in your RAG application. And now I believe, James, you have something very nice for us.
Yeah, absolutely. So we're really excited to announce the continuation of the Azure AI Advantage free offer. So if you're using Azure AI services or GitHub Copilot, you may be eligible for up to $6,000 free Azure Cosmos DB credit for 90 days. So you can check out this link to learn more, aka.ms/Azure AI Advantage blog for full details. But it's a really great way to get started. You know, it's already very cost effective and very cheap to get started in Cosmos DB. But now as you bring your applications to development and then to production, really great way, really great incentive to keep on using Cosmos DB for those AI apps.
We've got data storage covered with Cosmos DB, but you're also likely to need other tools and services in your AI app development journey. For example, you'll need a way to deploy and scale your APIs in production. To cover this, let's have Chris walk you through the Azure tools and services that make sense to use together with your AI apps.
Hey there, and welcome to this video. My name is Chris Noring. I work at Microsoft. Let's look at the agenda for this video and this presentation here today. First off, we'll look into AI apps, what those are, what different types of AI apps that you can build, because there is more than one. Then we'll talk about tooling and how our recommendation is a CLI tool here called Azure Developer CLI or ACD. We'll also discuss architecture because there are a few different choices. We will go through container-based and serverless. And we're not going to have a strong opinion each way, but more explain where one of them may or may not fit your needs. Then we'll talk about how we can manage APIs in production, because getting them into production is great, but you need to keep track of them for the sake of cost, for the sake of fair usage, scaling, security, and a lot of other things. But we will explain that as part of this video. So let's have a look and discuss AI apps, because there are three major apps that you could be building as an application developer. Either you are building a chat app, in which case you are integrating OpenAI, or in this case, Azure OpenAI, with your app, and you send a prompt and you get a prompt response. And that's great for a lot of use cases, but often we want to have a look at something called RAG apps, or Retrieval Augmented Generation. What that means in short is that you want the ability to speak to your own data, to search your own data. And for that to be possible, your data, first off, you need to identify which part of your data should be searchable, and then you need to turn it into a vectorized form, and then it's ready for search. To do all that heavy lifting for you, we are recommending Azure AI Search, and for storing all that vectorized content, we are recommending Azure Cosmos DB, and of course, Azure OpenAI as a service. And for your PDFs, for your Word files, CSV files, all that static content, we are recommending Azure Blob Storage. Now, thirdly, you might have a bit more advanced AI app, so-called an assistant, or, a simple type of agent. But agents can also be very complicated. They could be goal-oriented and very autonomous. But what happens here is that we combine the skills of different AI apps. So we give them the capability to run functions on our behalf, to do RAG, Retrieval Augmented Generation. And for all of that, we're gonna, in the cloud, use Azure AI Search, Azure Cosmos DB, Azure Blob Storage, Azure Functions maybe even, and some kind of agent-based framework. So you can see how there are different use cases. So find those services that you need for your use case. Now, taking your AI to production, that's a very interesting conversation to have. So first off, you want to deploy your solution to the cloud. So getting from local environment to the cloud, that's a great win. But we think by using the Azure Developer CLI, we are making this an almost frictionless experience for you by you deploying an entire solution. And then we want you to have a think. What about architecture? Because what architecture you select kind of also gear what services that you can use with it. But the good news is that most services can be combined with each other. But the choices you essentially have here is a serverless-based platform or a container-based one. And for those of you who don't know what serverless is, think about it as code running for a reason, or event-driven architecture. Something interesting happens, so therefore some piece of code should run, and maybe it should trigger an event in turn. Now, container-based is fascinating. If you haven't heard about containers, the idea is that you have a programmatic, lightweight environment in which you say, in this environment, in this black box, I decide exactly what frameworks, what libraries goes in there, what environment variables, how to build, how to run my app. And the good news with containers is that it's most likely going to have the same kind of behavior even in production. So containers are a great way to ensure a very common experience throughout. So you don't have any bad surprises once you deploy. Lastly, we want to cover monitoring, scaling, and protecting your APIs, because ultimately you are doing this as a business, right? Which means you want security. Our recommendation here is managed identity over API keys. API keys are great to start out with, but they have problems around them, like having a very fine-grained experience with different roles, admins, normal users, somewhere in between. You don't have the same level of control, and it takes a while to replace API keys if you want to change them for whatever reason. So please consider managed identity, where Azure manages identity and access for you. Then we also want to talk about scale, how to load balance. because we know as more and more users use your app, congratulations, you are a success. You still need to consider load balancing to make sure that the load is even throughout all of your endpoints. And then, unfortunately, we need to plan for being resilient. And that means that we need to plan for errors happening. So we have patterns like short circuit, where we can just say it to a resource, hey, you're on a timeout. I'm not going to speak to you for the next 15 minutes. Meanwhile, speak to all of these endpoints instead. So this would then give the erroneous endpoint a chance to recover. And then once it's playing well, it can be let back in to support your users. Lastly, let's talk about monitoring. For putting things in production is great, but you need to be on top of things. So you need to monitor logs. You need to check token usage, not only for fair usage among your apps, but also that you are not overspending what you have in mind. Let's talk about tooling. We mentioned tooling initially, but what Azure Developer CLI or ACD is here to do is to make you faster, to accelerate the process in which you go from your local environment to Azure. So Azure Developer CLI is an open source CLI tool. That means it runs in the command line, and it helps you deploy an entire solution, front end, back end, storage, the works. And what it provides you is a developer-friendly environment with some great commands, but also support within your terminal, your editor, your integrated development environment, and for CI/CD. Having a look at the workflow, how this works. So imagine now that you have opened your terminal window. The first thing we want you to do is to run ACD init. This will help scaffold your project. So you're going to be asked some questions around what is your project, and then it will kind of create infrastructure files for you. The next step we want you to take once you do that ACD init, which you do once per project, then you do ACD up. And this is to package, provision, and then end up deploying the app. And then lastly, we want you to do ACD deploy and you would run ACD deploy to update your code, update your infra, and then quickly deploy those changes so you can see that live in production. So this is how you can definitely get started with ACD. So before you do anything else, we highly recommend you to go to the template library here that we have shown a link for. The idea is for you to search for what you want, what you need. Maybe you're running a Python app, maybe you're running something .NET. I'm positively convinced that we have a template that's already been created for you, so you can get started in minutes. So go to this template library, search for what you want, and you can see here on your bottom left side how we have the ACD init command where we use the -t for template, and you simply select the template that you want and it ends up scaffolding that product for you. So definitely leverage our template library before you start doing things from scratch. What about architecture? Let's talk about architecture. Let's talk about the fact that we have two different choices and we just need to decide on one of them. On the one hand, you have the event-driven idea that code runs for a reason because something happens. For example, you as a company, you get a new customer, and most likely that's an important business event that leads to maybe an insertion in a database, maybe someone being sent an email, maybe you can just imagine the triggering of a lot of different operations. Azure Functions has a role to play here to carry out a lot of these tasks for you. And it's also part of the backend with Azure Static Apps. So that's also worth remembering. Then you have container-based on the other hand. As I mentioned before, containers are these lightweight black boxes that ensures that the environment looks the same in development as well as in production. They're fantastic, but you can also scale them in the millions. So you might have a few hundred users, but now you want users in the millions, and you might use something like Azure Kubernetes Service or Azure Container Apps to take you there. So let's talk a little bit about serverless now with Azure Functions. Now that we mentioned what serverless is, it's event-driven and Azure Functions has a role to play. Let's talk high level about the crucial concepts that you need to know about? Well, the trigger is important because the trigger defines when something should happen. So maybe someone uploads to a blob storage, maybe someone places a message in a queue, maybe there's a web request, or maybe time has elapsed. That's your triggering event. And so we have different triggers for you. And then there's also the notion of bindings. And bindings is code written to communicate with something on Azure. And this is code you don't need to write. So the idea with a binding is to make it super simple to insert into a database or create a message in a queue and so on. So define which trigger you want, but then leverage the bindings to make it super fast to write that code. But you could also combine products. So you could, for example, combine Azure Functions with Azure Container Apps. So it's not just used in one context. Looking here on the bottom right side, you see a scenario that I've been mentioning so far, but now you see it a bit more visually. So imagine now that this scenario kicks off when a user uploads a file to a blob storage in the cloud. What happens then is that this is a triggering event. So you have an Azure function that now runs that looks at the file that was inserted, and it validates its content, it processes the data, and it ends up maybe putting this in a message queue, or maybe it ends up triggering an email in turn. The point is something important happened and an Azure function responded. Let's talk about Azure Static Apps, because that's an excellent choice. So imagine now that you're starting out very simple. You have an index.html file, that's all you have. You just want to deploy that on Azure. Azure Static Apps is fantastic for those simpler scenarios in the beginning. But as your app starts to flesh out, as you start to have more pages, maybe a backend, maybe you want to secure it, Azure Static Apps is still here for you. So imagine that progressive adding a feature and Azure Static Apps is there for you, then you get the idea. But one of the great features about Azure Static Apps is also the fact that it sets up your developer workflow. So imagine the first time you are deploying using Azure Static Apps, it actually sends up a CI/CD pipeline for you using GitHub Actions. So imagine now that you have done this once, you have your application in the cloud, and next time you do a change, you do so with a pull request in GitHub, and you end up merging that to your main branch. Now Azure Static App picks up on that change and ends up redeploying that. So imagine that. You do the first interaction with Azure, then you forget all about Azure, and then you just manage Git and GitHub, and that's how you want it as a developer. So great experience for developers for sure. So let's have a look at the features here also on the right side. And you can see that you're getting global hosting, you're getting API functions with Azure Functions as your backend, you are getting a streamlined build and deployment, and you also have different environments. And we all know how great that can be to have a staging environment, a production environment, so you can test things before your end customer sees it. And as I mentioned before, the CI/CD is set up that very first time that you deploy. I also want to get your attention on this one. Azure Function can actually be combined with Azure OpenAI. And if you remember what I said about Azure Functions and serverless, we had the notion of triggers, why something happened, and binding, code that makes it easy to interact with other things that you can combine with Azure Functions. You can see here how it can do a lot of things for you. So here you have input bindings, you have triggers if an assistant does something and so on, or maybe if you do something with an embedding when you're making your content searchable. So you can see how this doesn't have to be hard. Combining Azure Functions and Azure OpenAI, I would argue, is being made a lot easier by these triggers and bindings existing. So check those out if you're interested in that combination. Moving forward, let's talk about Azure Container Apps. Azure Container Apps is a great solution if you are considering a container-based approach. It is a serverless platform, so you maintain less infrastructure, you save a lot of costs while you run container-based apps, and who doesn't want to save costs in the cloud? This is great to use for API endpoints, for background processing jobs, for event-driven processing, for microservices. And if you look at the platform itself here on our right side, we see that you have automatic scaling, and it scales up or down depending on various scenarios happening. So maybe there's an increase or decrease in traffic, then it scales to fit, or there's some event that happens that enables it to scale up or down, or maybe there's some CPU or memory load, in which case it will also say, okay, I'll create more resources to meet the demands of the users. And it supports continuous deployment, code push, app deploy, and a lot of other goodness, as you can see. And it also integrates with Dapper. So if you're all into microservices, specified services that are good at really one thing, you get a very rich programming model thanks to this integration. So you get observability. Who doesn't want to observe your app, right? PubSub, you get service to service, retries, and much, much more. So this is really a rich experience. And as with anything container-based, you can really choose what runtime you want to run on it. So choose your programming language, choose your development stack, and use what you need with Azure Container Apps. So currently we are limited to Linux-based container images, but bring your Linux, bring your Windows to the cloud. We don't care, just use the cloud. So let's talk about our last chapter as part of this presentation, how to scale, how to monitor, and how to protect your app. So if we're looking here at Azure API management, it's a so-called turnkey solution, which means it's a great solution once you publish a few APIs or quite a few APIs and you want to manage that towards external and internal customers. This is a solution that kind of works for you. So the idea is to have a gateway in place between the user request and your end API. And within this gateway, we can define various policies to make it easier for you to say that this person should have access, this person shouldn't have access, and so on. And you can really manage groups really, really, really well. And you have this sense of end-to-end management as well. So you can use managed identity, you can make things scalable, it's a reliable way of publishing and consuming. And yeah, it's really great end-to-end experience once you start having a few APIs to manage. What's good to know though is the context in which Azure API management shines really well, and that context is AI. So it's a great companion service. So imagine now that you have provisioned Azure OpenAI. Our best recommendation here is that you put Azure API management in front of that. And why is that? Well, it comes loaded with a lot of policies that will make life easier for you. So for example, you got token limit policy, which means that you can ensure that not one of your application takes all the resources, but you can say, hey, you over there, you get 25% or N number of tokens, and that's all you get in this time window. So then you can ensure that other applications trying to use that same Azure OpenAI resource, that there are tokens ready and available for them. But of course, you want to measure all this, right? You want to measure what goes on, probably show that in a dashboard. And this is where emit token metric policy comes in. It's really great at collecting all those metrics, how things are being used, what application are using it, what user is using it, and so on. So you can have a really nice overview of the situation about how AI is being used within your apps. And then you got something called load balancer and circuit breaker. Now, load balancer is great because it ensures that you can always make sure that the end user has access to that API or access to that backend. And the circuit breaker makes sure that your app is acting like a resilient app. So there's no outages that affects the end user experience, but you seamlessly make sure to point your user towards a working backend because you're going to have more than one. And then you have a notion of semantic caching policy. And this can greatly improve not only your cost, but your performance. Because if you have a lot of similar requests going through from a user or users, then you can instead respond with some cache response. And yeah, that could greatly speed up the end user experience, not to mention be very easy on your cost management. So we have come to the point where it's time to kind of sum up the whole situation. So what are we saying? We are saying Azure Developer Tools, ACD, Azure Developer CLI is our best recommendation for deploying whole solutions. We think that you will select between a serverless architecture involving Azure Static Web Apps or Azure Functions, and or a container-based one with Azure Container Apps, because as I mentioned, Azure Functions and Azure Container Apps could definitely be combined. But now you have a mental model of those two different options. And what we said here last about API management, once you put Azure OpenAI in production, we really recommend that you put API management, or APIM as it's also known, in front of it. Enable all those policies meant for Azure OpenAI to make sure that it's secure, that it scales, that you keep track of cost and usage in production. Thanks for watching. My name is Chris Noring, and stay tuned.
Now, thanks to Chris, you're in serious business. At this point, you've got your AI models, you know how to store and manage your data, and you're ready to deploy your app to the cloud. For the last section, we'll talk about improving the user experience of your AI apps on the front end. Rohit will cover why and how to stream generative AI outputs using the AI chat protocol.
Hi, my name is Rohit Ganguly, and I'm a product manager here at Microsoft. Today, we'll cover streaming generative AI output with the AI chat protocol. In terms of what we'll cover, first, we'll cover streaming GenAI output as a whole. Then, we'll introduce the AI chat protocol. And lastly, we'll dive into a usage sample. First, let's cover streaming generative AI output in your application. You might be wondering, why use streaming to begin with? Simply put, it's the expectation for GenAI apps these days. It results in reduced latency from seeing the output from the model, and also an enhanced user experience. When it comes to streaming, there's two options for implementing it. First, you can use a GenAI inference SDK directly in the browser. Alternatively, you could use an AI inference server to stream to your client. We'll cover both of them. The first option for streaming is inference in the browser, and this is the simplest one. It's done by using the inference SDK in the edge device. So for example, using the Azure OpenAI SDK for JavaScript in the front end. The front end would be running the inference SDK, and it would directly call the AI model service. This results in easy streaming to UI, but unfortunately, it ends there. Unfortunately, browser-side inference is unsafe and not best practice. From a security standpoint, there's API key exposure in the browser, and no sanitization of the input, meaning that users can potentially maliciously send content to your model. Additionally, if you have data compliance requirements, there's no integration with that. From an application standpoint, there's also no rate limit and quota handling, as well as no caching, which means performance and cost can go up. There's no integration with business logic since you're directly calling the AI model. As such, no handling of excess data, which can result in more costs. The best alternative to running inference in the browser is to have an AI inference service in the middle. This means a server would sit in between the user's device and the AI model service. This gives a clean separation of concerns with AI inference and backend logic. The added challenge here is that streaming to the client and UI is now tricky. For example, the client's browser could send a post request giving the chat. The inference service would now have to handle the call to the AI model service using something like an inference SDK. While getting this stream is easy, we now run into an issue where we need to send something back to the user. This process turns out to be very tricky. First, you need to select a network protocol for streaming, such as HTTP, WebSockets, or server-sent events. From here, you need to now define the exchange format of what things will look like when you're sending things back and forth. Lastly, you need to parse the output, which could be hundreds of lines of browser-side JavaScript to write, specifically for your application. Remember, from the diagram before, we now have to figure out the piece between the client's browser and this middle tier. Fortunately, we have the AI chat protocol, which is designed to solve this problem. The AI chat protocol is designed to make streaming easy. There's only two requirements. First, your server needs to use the API specification defined by the AI chat protocol. From there, the front end would now use a lightweight parsing SDK that we've created. There's one client, the AI chat protocol client. There's also two methods that you can use, the getCompletion method and the getStreamCompletion method. The getCompletion method is synchronous, and the getStreamCompletion method gives an asynchronous stream that you can iterate through. This gives you easy streaming along with TypeScript models. Additionally, if you have any application context you'd like to pass back and forth, we have an options bag for any other data you might need. Here at Microsoft, we make a lot of AI samples, and using the AI chat protocol has helped us build things even faster. Johan Lasorsa, one of our cloud advocates, estimates the AI chat protocol to remove something like 200 to 400 lines of code within one of our samples. When building with the AI chat protocol, it's important to note that it's a server to client only design pattern, not server to AI model. This means that all of your AI backend choices are flexible. You can use any orchestration, such as LangChain or semantic kernel. You can use any RAG option, such as Azure AI Search or something like PG Vector. You can use any programming language you'd like, and also any language model you'd like. The way it would work is simple. Your client browser would use this lightweight SDK that we talked about. It would then send a request to the server that you run, which adheres to the API spec that we defined. Your AI service would then handle any orchestration or any RAG or anything else that you'd want, receive that output, and send it back according to the AI chat protocol. Your front-end browser would now have an easy way to iterate through all of the messages coming through. Adding the AI chat protocol to your application is actually very simple. On the right, we see a diagram here with a serverless API that calls Azure OpenAI Service, Azure AI Search, and Azure Blob Storage. The serverless API performs retrieval augmented generation, or RAG. We also have a web app that calls a serverless API and handles the content being sent back and forth by the user via chat interface. In terms of how we'd add the AI chat protocol to this example, first, we want to ensure that the service API conforms to the chat protocol spec. Second, we want to incorporate that SDK into our front-end code so we can easily parse the output. And that's it. We can now enjoy streamed output to the client. Let's dive into a sample. If you'd like to see the sample, it'll be linked at the end of this presentation. The sample we'll be using is a serverless RAG with LangChain.js sample, following the same architecture pattern that we saw in the previous slides. The sample uses the AI chat protocol for streaming to UI. There's two core pieces of this sample. First, there's the RAG service API, which conforms to the AI chat protocol API spec. The web app is a second component and uses the AI chat protocol library. Below, we can see what the UI would look like for a user using this application. First, let's jump into the RAG service API. This function creates a new line delimited JSON stream, which is what the AI chat protocol uses for streaming. It takes response chunks from either a RAG call or an AI model call and transforms it into the stream we'd like. On line 109, we can see that we create an AI chat completion delta for each of the response chunks that we receive. We then, on line 118, turn those into JSON strings and send them back one at a time in a generator pattern. Diving into the post endpoint of our API, we see on line 86, we create a response stream from our RAG chain, which uses LangChain.js underneath. This response stream is then formatted into that JSON stream that the AI chat protocol API spec uses. On line 92, then we return that with the content type application x-new line delimited JSON, and we set the transfer encoding to chunked. This API now conforms to the AI chat protocol. Now let's jump into the web app. On line 1, we import the AI chat message, chat completion delta, and AI chat protocol client from the AI chat protocol library. On line 5, we set our chat request options. First, we set our messages, which are of the AI chat message type. We then set a chunk interval amount of time, and then the API URL for the endpoint that we want to target. Next, the web app has a function for getting completions, which uses the AI chat protocol underneath. On line 13, we can see that we take in the API URL from our chat request options and set our endpoint URL. On line 14, we then use the getStreamCompletion method and have a result, which we can iterate over on line 16. We ignore everything that's not a delta, and on line 21, we yield a promise. Now, whenever we send a message to the AI endpoint, we get a response back that's streamed in live time. Additionally, it can pass anything that we want, such as application logic or context. That's all it took to stream generative AI output to your application. If you're interested in the GitHub for the AI chat protocol, it's available at aka.ms/AIChat. If you're interested in the API spec, that's available at aka.ms/chatprotocol. If you want to give the sample a shot for yourself, it's available at aka.ms/ai/js/chat. Thank you so much.
That's it for this video. You've learned a lot about building generative AI apps with practical tips, examples, and tools to help you along the way. I hope you enjoyed this course and you're now ready to build your own AI apps with JavaScript. Stay tuned for more content and happy coding!